Do you know what this is? It's like useful like electromagnetic fields.
So you can have a function of a magnetic field.
So this diagram is called a slope field. So it's a field of slopes, or a field or a diagram of all the gradients for certain x and y values. Today I'm going to get you to draw some slope fields. Sketch the slope field for the differential equation dy dx equals x over 2 for those y values and for those x values. So what's going to change in this equation if we sub in numbers? Yep, the gradient. So going back to year 9 and 10 maths, rise over run, dy dx, the gradient, the slope. Okay. So what do we need to sub in to change the slope? Has to be x values, right? If we sub in y values, well, there's no y, so it doesn't matter what the y value is. We will do that next. So you have to first look what is the derivative in terms of. Okay, so here's my handy table. The derivative is in terms of x, so that's going to be our first column. The second column is all the different slopes or gradients. So let's start with x equals -2. We sub it into that, we get -2 over 2, which is -1. Does that make sense? The last column is the angle that it forms. So what is the angle that slope -1 forms? Rise of -1 and run of 1, 45. Let's go just drawing these two before I keep going. So at x equals -2, and it doesn't matter what the y is, so let's just make y 0, because there's no y in here. So y equals 0, x equals -2, the angle is -45, like that. So how I did this, go from there to there, that's an angle of 45 degrees, and you draw a little straight line at the point x equals -2, y equals 0. So all of the y's, doesn't matter what y is because there's no y, at x equals -2, they will all be -45 degrees. We'll go to this one, x equals -1. It is 27, which is rise of 1, run of 2. So it's that angle there. So it looks a bit like that. And it doesn't matter what the y is, they're all going to be the same slope. Table x equals 0, so at this point, all along here, x equals 0, what's our dy dx if we sub in x equals 0? 0. So you may remember that looks like a flat line I said before, because the angle is 0 or the slope is 0. So if we subbed in 0 into tan -1, you would get the angle. There you go. terms differential equation or slope equation in terms of y. So let's try this. Same sort of table again, but it's in terms of y. So what's the first column? So we're going to try for all these different values. For y, you get -2 over 2, which is -1. So the slope or the gradient at y equals -2 is -1. And we figured out before what was the angle if the slope is -1. -45 degrees. So again, you can sub that into tan -1. Sub in 0, you get 0 again. Sub in 1, you get a half. Sub in 2, you get 1. So it looks like a very similar table to last time, but the slope field is quite different. So at y equals -2, all the way along here, the slope is -1. So it doesn't matter what the x value is because there is no x. All of the slopes there are 45 degrees or -1. For the second one, y equals -1. So on the y-axis, y equals -1. You've got rise over run, so you get an angle of 27 degrees. For y equals 0, you've got 0 degrees. For y equals 1, you've got 27 degrees. And for y equals 2, you've got a slope of 1 or a slope of 45. So this time it's symmetric around this axis, which is the x-axis.